Started.
Hello everyone, this is Anchita Ramani from Section C and I am here with my team.
Hi everyone, I'm Srishti Raj.
Hey everyone, I am Devraj Bharti and we are here to present our DS assignment. And here it begins. Now, what is minimum spanning tree? The definition of minimum spanning tree says that when you can convert a graph into a tree such that it contains exactly n nodes and n minus 1 edges, then we can tell that tree a minimum spanning tree.
Now the properties of minimum spanning tree. The graph for the minimum spanning tree should be a weighted graph and every node should be reachable by the other node. Uniqueness. If each edge has a distinct weight, then there will be only one unique minimum spanning tree. Minimum cost subgraph. If the weights are positive, then a minimum spanning tree is in fact a minimum cost subgraph connecting all vertices.
Cycle property. For any cycle C in the graph, if the weight of an edge E of C is larger than the individual weights of all other edges of C, then this edge cannot belong to an MST. Cut property. For any cut C of the graph, if the weight of an edge E in the cut set of C is strictly smaller than the weights of all other edges of the cut set of C, then this edge belongs to all MSTs of the graph. Minimum cost edge. If the minimum cost edge E of the graph is unique, then this edge is included in any MST. Contraction. If T is a tree of MST edges, then we can contract T into a single vertex while maintaining the invariant that the MST of the contracted graph plus T given gives the MST of for the graph before contraction.
Now, we'll look at the few applications of minimum spanning tree. The first one is the cluster analysis. Clustering points in the plane, single linkage clustering, a method of hierarchical clustering, plus the graph theoretic clustering and the clustering gene expression data. Next come is the constructing trees for broadcasting in computer networks. On Ethernet, computer networks, this is accomplished by means of the spanning tree protocol. Next come is the circuit design, implementing efficient multiple constant multiplication as used in finite impulse response filters.
Now we have various algorithms to obtain minimum spanning tree and Kruskal's spanning tree algorithm is one of them. So this algorithm is used to find the minimum cost spanning tree using the greedy approach. This algorithm treats the graph as a forest and every node it has as an individual tree. The steps are as following. Step 1. Remove all the loops and parallel edges. And in case of parallel edges, keep the one which has the least cost associated and remove all others. The next step is to arrange all edges in their increasing order of weight. That is to create a set of edges and weight and arrange them in an ascending order of weightage. The last step is adding the edge which has the least weightage.
The second algorithm is the Prim's spanning tree algorithm, which is in contrast with the Kruskal's algorithm, treats the nodes as a single tree and keeps on adding new nodes to the spanning tree from the given graph. So the three steps for this algorithm is step 1, remove all loops and parallel edges. Step 2, choose any arbitrary node as root node. And step 3, check outgoing edges and select the one with the less cost. So with this, we end our PPT and thank you everyone.
Thank you everyone.
Thank you, everyone.